The marine industry currently relies mainly on hydrocarbon-based fuels derived from crude oil. Burning these fuels produces water and carbon dioxide. In addition, because they are derived from crude oil, products of combustion include many contaminants, notably oxides of sulfur, SOx, particulate matter, PM, nitrous oxides, NOx, and traces of contaminants such as sodium and vanadium. A range of legislation such as emission control areas, ECAs, has already been introduced to try and limit the damage from these products of combustion, but ultimately to reduce global warming, the marine industry needs to drastically reduce the amount of CO2 and other greenhouse gases produced by shipping. In 2023, the IMO's target was to reduce CO2 emissions per transport work, as an average across international shipping, by at least 40% by 2030, pursuing efforts towards 70% by 2040 compared to 2008. For total greenhouse gas emissions from international shipping, the target is a reduction of at least 20%, but striving for 30% by 2030 compared to 2008. By 2040 to achieve a reduction of at least 70% greenhouse gas emissions, and then by 2050 to achieve net zero greenhouse gas emissions. These targets are only likely to be met if the use of new fuels is encouraged, and therefore a further target of the IMO is that zero or near zero emission fuels will represent at least 5%, striving for 10% of the energy used by international shipping by 2030. There are other possibilities, such as biofuels, nuclear and battery power, but we will concentrate on 4 new fuels with the potential to reduce greenhouse gases. These are liquefied natural gas, ammonia, hydrogen, and methanol. In order to evaluate the potential of any fuel to reduce greenhouse gases, it's important to consider not just how much greenhouse gas is emitted when the fuel is burned, but also how much greenhouse gas has been emitted to create and transport the fuel in the first place. The total emissions associated with a fuel are often described as the sum of the upstream, well-to-tank, and downstream, tank-to-wake emissions. In a similar way, the terms blue hydrogen and green ammonia and green ammonia are used to differentiate between how these fuels have been produced. Green fuels are those produced using energy from renewable sources like wind or solar power, with no harmful greenhouse gas emissions. Blue fuels are those whose production has resulted in greenhouse gas emissions, but where, for instance, the carbon dioxide produced as a byproduct has been trapped and stored using carbon capture and storage, CCS. The space required to store the fuels on board depends on their energy density. This is how much energy we can get out of a given amount of fuel, either per kilogram of fuel or per liter of fuel, since both the mass of fuel needed for a voyage and its volume will affect how much cargo can be carried. For any of these fuels to become widely used, they must be reasonably available worldwide and at an affordable price. However, as with other green technologies such as wind power and solar power, history has shown that once new technologies go into mass production, costs come down dramatically and more production facilities come on stream. Most importantly, these new fuels must be capable of being transported, stored, and used safely, and each of these new fuels has its own issues, which must be properly dealt with. Which of the following can be produced by burning hydrocarbon fuels produced from crude oil?